and talking about building high value monitoring as a practice. This isn't going to be completely Sysdig focused or anything. It's more talking about the general practice of monitoring. So I'm going to get right into it. Just get that going. And all right. So for this presentation, I'm going to do a quick definition of what monitoring is as far as we're talking about it here, why we do it, how do we measure quality. I'm going to talk about things, some types, some perspectives, and different uses of monitoring. How do we get raw data for monitoring and some of the analysis techniques we can use on that raw data. I'm going to talk about what does it mean to define good for your service so that you can wrap your monitoring around that definition, some best practices around alerting and dashboards, and then go over a Sysdig Live demo about putting some of these to practice live. So monitoring is what I'm talking about here is collecting, processing, and displaying data about a system and its component. And I'm just using the word system. You could call it a service. The purpose of monitoring is to help us keep our system running and understand how it behaves over its entire life cycle. It's not just to catch and troubleshoot service issues live. That same data is useful for capacity forecasting and cost and growth, identifications of bottlenecks in the service, and help focus improvement efforts. That developer time is limited. It can help direct where those resources should go. And it's all about using qualitative data to make some of these decisions rather than our instinct and our intuition or gut feelings. Having hard data can make all the difference in the sort of value you get out of that developer time. Monitoring is a lot of times people think of monitoring as like a binary thing that either yes, you have monitoring or no, I don't have monitoring. But it's really monitoring itself is a system with a wide range of quality. Good monitoring is a force multiplier in your organization that with good monitoring, it answers a lot of questions. Bad monitoring can lead people kind of down the garden path. Some of the quality aspects of monitoring is how frequency do you get false negatives or positives, where a false negative would be we didn't get an alert. Our monitoring didn't tell us we had a problem when we clearly did. You know, we had to wait for our users to tell us. A false positive is when your monitoring tells you you have a problem, but you go and look and it turns out, no, actually, everything is fine. Other aspects are the time to catch a service issue. Do we have the right tools and data that when we do have an issue, can we track down what's happening? Do we know when and where we need to add capacity to our system? And how much does monitoring cost? There's monitoring isn't free. There's usually a cost, not just in software licenses, but also in the resources spent to offer up that monitoring. All right, do I still have everyone on the call? Still working? Shelley?
Yes, you do.
Okay, just making sure.
Yeah.
So a monitoring platform, it typically has a number of capabilities. So you have the first step is you have to instrument your metric and your event data from the different sources and domains. By sources and domains, I'm talking about applications, hosts, your storage, your network devices. Typically, the way to get data out of all those different things is going to be different. Then you have to collect the data from all these different sources. Usually you pull it or sometimes you push it. You have to store the data somewhere. Then you have to do analysis on processing on that raw data. Usually that raw data by itself isn't very useful. So you need to do some further analysis. That can be things like correlation, sampling, aggregation, histograms, percentiles, all that good stuff. Then alerting and notification is usually a big part of monitoring. So setting thresholds and notifying people or other systems about things that are happening or that monitoring has detected. And then the visualization. So that's around the dashboards and graphs and tables and traffic lights and heat maps. And that can be real time, but it can also be historical. There's lots of different open source and closed source monitoring platforms, and they typically offer all of these capabilities or maybe some combination of them. And they're usually generally focused on a particular domain. So either the application layer or the storage layer. There's no one platform that does everything for all possible domains, but usually the good platforms will offer up APIs so that you can get data in and out of them and feed it into other platforms that do have the capabilities that you're looking for. So Sysdig Monitor is one of the platforms that's out there, and it's focused on collecting metrics and events from Kubernetes clusters and their workloads and doing visualizations and alerts on them. So it has a bunch of APIs and libraries to do that instrumentation and collection of those metrics from all those sources into the platform. And it also provides some data that if you want to pull data out of Sysdig, the APIs are there to grab it. For the purposes of the demo here, I'm using kind of Sysdig Monitor out of the box features, but you can feed custom metrics into Sysdig. So if you have JMX metrics or StatsD stuff or Prometheus, those can also be fed into Sysdig. So I'm going to talk a little bit about service monitoring, terminology around monitoring. So we have a system, and we build the system because we want it to provide one or more services to people. The system is a collection of infrastructure, and they're all working together to provide this service. So when I'm talking about service monitoring, I'm talking about data about how the service is performing whatever its purpose is to its users. Infrastructure monitoring is focused on all those different infrastructure components that make up the service that we're offering to our users. Both of them are needed. You can't have one without the other to have a complete monitoring picture. Another monitoring terminology is black versus white box monitoring. So white box monitoring refers to looking at your system and you can see all the internals. And black box monitoring is more focused on the inputs and outputs of the system. And I'm going to go into that further with monitoring perspective. So here's a service that I've very small that has some users that interact with the front end service that's made up of some Python apps, which use a backend service to talk to Redis. This would be a white box view monitoring perspective of the service. But if I was to look at the service from a user's perspective, it's just a black box. They make requests to it and hopefully get the response that they were looking for. They don't know or care about what's happening on inside the black box. Starting out in monitoring, this perspective is a great place to start because it provides visibility into how the service is working as far as users are concerned. Another perspective might be, I'll give an example here. If I was a front-end developer, I know some of the inner workings of this Python app that makes up the front end, but I don't know what happens on the back end. So the back end is a black box to me. And if I was going to create some monitoring artifacts for a front-end developer, I would take some of those metrics from the user's perspective, but I might add some additional metrics about the inner workings of the Python app, maybe CPU or queue sizes or individual worker data. I might also want a different aggregation of the data. Maybe I want to see response time by different versions of the application that I'm running. You can keep this perspective model going and create a perspective for a backend developer or your infrastructure administrator or your networking team or your storage team. Each perspective is of the same service, but looking at it from a different view. So with that black box monitoring, that's how you do service monitoring. It's a visibility of how a service is performing, whatever its function is overall. And it's a great way to identify when you're having an issue. White box monitoring, the infrastructure monitoring, is telling you how the components of a system are functioning. And that type of monitoring is helpful for figuring out why the service isn't performing as desired. So more on that, we can look at things from symptoms and causes. So a symptom of an issue is what is being broken. So a symptom could be that users have very high response times to the service. The cause would be, well, why are they having very high response time? So uh, a possible cause could be, well, there's high CPU on the worker pods. We're not able to handle the volume of load hitting them, and that's why we have high response time. Now, the cause of high worker load could itself be a symptom. That may be the reason that we have high CPU on the worker pods is that we've had a sudden burst of requests far greater than what we've architected for. So symptoms can become causes and causes can become symptoms. When setting up monitoring, focusing on symptoms, that service level symptoms, helps cover many potential causes and gives you the most value for your effort. So rather than trying to figure out all the different ways your service could break and trying to set up monitoring around all those different ways, the biggest bang for your buck is to start off with measuring at that high level, at that symptom level, as your users see it. So the two ways to collect monitoring data about those interactions with your service, you can do synthetic monitoring where you create a request against your system, your service, your component, and collect data about how that request was handled. How long did it take? Was it successful? Did it get the expected response? Passive monitoring is about collecting instrumented data from the systems and their components based on the real requests from users flowing through it. So synthetic monitoring is usually the easiest to set up. It collects data about how the system is performing when you give it a known request payload. And this can be really useful if your service doesn't have a lot of traffic, so there's not a lot of customer passive monitoring to instrument, or it's just not possible to instrument your application for whatever reasons. The issue with synthetic monitoring is that it's hard to get a good, true reflection of users' experience with synthetic monitoring because the size and shape of user-driven requests may be very wide-ranging with many different paths through your system. And it might be hard to really create a true synthetic version of certain types of requests. But it's okay to use synthetic monitoring if passive monitoring isn't really an option. So as far as what should you instrument, what metrics should you select in monitoring? There's a couple of common methodologies that are used. There's the golden signals that refers to latency, traffic errors, and saturation. There's also use red, which is slightly different, but more of the same. Latency is how long does it take to process a request. Error would be the rate of request failure, and that can be an actual error being generated, but it could also be that it was too slow to respond. It didn't meet your criteria for what success is, or any other type of criteria. Traffic and rate are really about the volume of requests, the number of requests, how big are they? Saturation is a measure of how close to capacity are we? And that can be a tricky one to monitor for because sometimes we just don't really know what our saturation point is. And what I recommend there is to start with, what's the architected capacity? What do we think the capacity is? And then as you collect real world data, you can tune that. You can use things like CPU and memory usage that have a 0% and 100%, but typically you're not really going to know what the true saturation point of your service is until you get some real world data. To get more value out of that raw monitoring data you're collecting, you can use segmentation of the data to get higher value from it. So rather than just average response time of all my requests, I might segment that data to say, well, what's the response time by successful requests versus failed requests? Or I might want to say, I have different request types. Some are small and really fast, and some are big and really slow. I'm going to separate my monitoring data out by that. And that's one easy way to get more value out of the same set of metrics. You can also use things like histograms and percentiles. A raw average can kind of hide some important information. So you can do things like give me the number of requests with a response time between 0 and 100, 100 to 200, 200 to 300, that kind of thing. Or a percentile to say, what's the response time that 95% of my requests fall under? And again, that can give you more data than just a raw average. A lot of the instrumentation libraries out there for all the different code, they support these out of the box. So you don't have to develop your own code for creating histograms or percentiles or any of that sort of thing. Another way to add value is to use aggregation. So that would be summing and averaging metrics across a whole bunch of different components. So if we had a pool of worker nodes processing requests, and we want to know, well, what's the service total? We can just sum the number of requests per worker to give us a total for the entire service, or you could average the request time across all the worker pods, and that would give us an average service response time. Averages have to kind of be careful with because sometimes it can be misleading. If you had a situation where, let's say, one pod was processing 100 requests in an average of 1 millisecond, and another pod processed one request in 1,000 milliseconds, depending on how you average it, you could end up with, if you average it by pod, the average is 500. But if you average it by requests, weighting more to the pod that had more requests, you might get a number like 10 milliseconds. So knowing where that data is coming from is important because it can be misleading if you just straight up average everything. Sampling is another another method of data analysis. It can be expensive to do instrumentation for every request that goes through the system. So one thing that you can do is sample a small percentage of those requests, like say 1% of them. And the accuracy of those samples depends on the sampling rate and the population size and the actual distribution. But a lot of times you can sample a very small number of requests and get a very good picture of what's actually happening in your environment. Resolution is another important detail. You can't collect and store data for every single request that goes through the system. It's generally not economical. And generally what we do is we collect data over a period of time and then write out a summary every period. So a common period might be 15 minutes or 5 minutes or 1 minute. The more granularity that you have, it's useful in finding some of those short spikes and dips, but there's a higher cost in infrastructure to collect and transmit, process, and store all that data. So there's a bit of a balancing game of value and cost, and using things like histograms and percentiles can help with that. It can be a lot of data in monitoring. I'll give an example that, let's say we're collecting 500 data points from all our application instances. Each one we collect 500 data points, and we have 50 of them, and each data point is, we'll say, 64 bytes. Over the course of a month, that works out to be around 60 gigabytes worth of data. So, and as you scale up by adding more data points, or you increase the granularity, that number can grow very, very fast. So one of the things to think about when defining and creating monitoring is just how much data are you really collecting here? So I talked about defining what good looks like. So for a system, we create them to serve some sort of purpose. And we need to be able to define metrics around how well are they meeting that purpose, not just for monitoring, but for system design in general. A lot of times monitoring ends up being designed to catch bad, but the problem being that there are many different ways things can be bad, and you can't monitor for them all. So if you have clear, well-defined expectations about what a service is supposed to be doing, and you define what good is, that provides a focus on where to put your efforts towards building monitoring. So this is where service level objectives and service level indicators come into play. So they're a framework for defining what good looks like, and it sets expectations for the service between all the stakeholders, the users, the developers, the architects, the operators. Having these helps set those expectations for both the users and the people responsible for the upkeep of that service. And this is crucial to designing good monitoring. Without these, you don't really know what you're supposed to be monitoring for. Now, a common service level objective that we see a lot is availability. And the issue I have with availability is, what does it mean for a service to be available? And the dirty secret is, a lot of the times availability is checked with something like a ping or a port test, which is a very weak indicator of whether or not the service is functioning. And by functioning, I mean that users can interact with the service and get the response that they expect. Another common check to check availability is to hit a status page with a synthetic check. And the code behind the status page could be a better reflection of the actual health of the service, although a lot of the times that status page might do something like, oh, I'll check that I can talk to the database. But that might not be a good indicator of whether or not the service can do work as we expect it. So the best SLOs are well-defined and reflect the different use cases of the system. So I've given some good, better, best type of SLOs here. So talking about a good SLO might be, well, the average time to complete a request takes 500 milliseconds. A better one would be a little bit more detailed to say, well, we expect 95% of the requests to be completed within 250 milliseconds. Even better would be to provide more details about what really is the service level objective. And we can say, well, we've got type 1 requests. We expect them to be complete within 300 milliseconds with a 200 level response code over the course of a calendar month. That level of detail is something that all teams can work off of, and it's easy to know whether or not you're meeting your SLO. Some good SLOs, though, they need to be reasonable. It has to reflect the actual reality of the service and its associated infrastructure, its architecture, the resources, and budget. It doesn't help to have a very lofty goal of an SLO, 5 nines or whatever, if the infrastructure isn't there to meet that SLO. Setting unrealistic expectations leads to wasted efforts striving for a theoretical goal. And you can actually end up with worse performance as more complexity is added to the service to try and meet the criteria, but on paper. But added complexity usually causes downtime and problems. But if it's an unattainable goal, that tends to be what happens. The SLO must be measurable, that the monitoring system needs to be able to measure that definition in real time. If it can't measure and analyze it, then it's not very useful. And then finally, the SLO should be accurate and should reflect what users expect from the service. If we have all our SLOs being met and the users are unsatisfied, then either we need to change the SLO or we need to change the user's expectations. Error budgets are a gauge for balancing the need of spending time and resources improving reality versus adding new features and capability. And they also provide a way of gauging the severity of an issue. An issue that's eating up the error budget quickly is more severe than one that's not. And I know sometimes errors can be a bad word in monitoring, that we shouldn't have any errors. But realistically, every service is going to throw an error every once in a while. And by having a service or an error budget, you can set a level of errors that are okay for the service. And as long as we're within budget, we can keep adding new features and capabilities. But once we start going over budget, or we're predicted to go over budget in the calendar month or the quarter, that tells us that, well, maybe we need to spend some time improving reliability. It's just a way of trying to help gauge developer time to say, when do we need to spend time on reliability and when do we need to spend time on features and capabilities. Now on to kind of a different topic about alerts and notifying. So when I'm talking about an alert, it's about defining a warning that some metric is breaking a predefined threshold over a time window. And a notification is about actively letting your operators know that an alert condition has been met. You could send a chat message, it could be an email, SMS. Alerts are used for identifying issues that require immediate attention, um, especially if you tie it to a notification. If it's something that you want someone to look into, but maybe it's not an alert, that might be better suited to a report or something a little more passive. Um, with alerts and notifications, you could run into problems with false positives. So that's alerts that aren't actually an issue, or maybe it just doesn't require immediate attention. Um, alert spam would be just a constant barrage of alerts over a long period of time. An alert flood would be a barrage of alerts when something breaks and a whole bunch of alerts all get sent about the same time. All those constant alerts and false positives will train those who receive them. They'll just eventually end up getting ignored. So false positives are a really bad thing in monitoring, and always something that need to be looked at over and over again. Some best practices around alerting, obviously those service level indicators that I talked about earlier, they're great metrics to put alerts on. You might want to make those thresholds tighter than what your service level objectives are so that you can catch problems before you actually violate your service level objective. You want to alert again on symptoms instead of causes. Before creating alert, look at the historical data. A lot of times I've seen people create alerts based on what the metrics look like at the time of day that they're creating the alert. But you've got to consider low usage periods or holidays, upgrades, maintenance windows, times when the data might look different. And if you create an alert, it's going to go off in the middle of the night anytime someone does an upgrade. You want simple alerts rather than complex alerts. A lot of tools will give you the ability to create these big long chains of if-then statements about when or when not to alert. Simple and reliable is better than complex and brittle. Don't use too tight a time window. Sometimes, when should I alert somebody? When this threshold has been broken for a minute, or should I wait 5 minutes or 10 minutes? Sometimes people will want the very tight time window under the idea of, well, I want people to know that there's a problem as soon as possible. So as soon as this metric is broken, send an alert. The problem will be that will create a lot of false positive. It's very common to see little blips in monitoring data that come and go without any fuss. If you're looking at the full mean time to repair of an issue, so that would be when the issue occurred, when we were notified, when we started working on it, and when we fixed it, you might have an MTTR of 3 hours. The idea of whether you alert after a minute or 5 minutes on the front end of the notification isn't really a big difference in the total MTTR of the problem. And if by setting that time window very tightly, you cause a lot of false positives, it's really not worth doing. Another common thing I see in a lot of monitoring tools is they'll let you alert based on historical data. So you could say alert if the response time is 25% above the historical average for this day of week, time of day. Now that usually sounds pretty good, like great, I don't have to think up thresholds. The system, the model will tell me what's abnormal and just alert when that happens. These systems tend to be more trouble than they're worth because any disruption in the data breaks the modeling, and it can take weeks for the broken data, the bad data to filter out. So holidays, a service issue, a burst of traffic, or a change to the service can change how what the average is supposed to look like, and you'll end up with a bunch of alerts that aren't actually problems. The important thing with alerts is they are regularly reviewed and updated. So if alerts are generating false positives, loosen the thresholds, get rid of them, or replace them with a better metric. Anytime you have a false negative, so there was an outage, but monitoring didn't catch it, that's a great candidate for identifying where more alerting can help. And to remember to always focus on symptoms rather than causes. Dashboards are a tool to visualize monitoring data. So that's graphs, tables, traffic lights, that sort of thing. They're useful for getting a view of the real-time status of the system and understand the impact of issues as they occur. And they can also help with pinpointing where the cause of an issue might lie. You can look at them with live data. You can look at them to visualize long-term trends. Best practices for dashboards. The golden signals and service level indicators are great metrics to focus your dashboards on. You'll want to create multiple dashboards for all those different perspectives I talked about earlier. There's no single pane of glass for monitoring dashboards. There is no one dashboard that will make everyone happy. Don't create giant dashboards with a whole bunch of noisy panels in the hopes that you're going to be able to capture everything that could possibly happen. They're usually slow to load, and it's really hard to visually correlate between what's happening between one graph and another. Dashboards aren't a replacement for alerting. Nobody's looking at a dashboard 24/7, but a great practice in your alert when you notify out, include a link to a dashboard that's relevant in the alert message. And you want your dashboards to be easily shared with other people, so use templates and variables so that you can share them between teams. So finally, I thought I'd mention logging. So a lot of people kind of put logging and monitoring, I'm doing monitoring because I'm logging, but logging to me is something completely different. They're very useful for low-level troubleshooting, but collecting, analyzing, and visualizing logs is an entirely different topic and set of tools from metric data. The volume of data in logs is typically orders of magnitude greater than metric data, and it can be really erratic. A service might produce 1,000 logs a second when things are running fine, but when there's a problem, now you've got 100,000 logs a second, and the system that does all that collection and analyzing has to be able to handle these big bursts in log data. What I would recommend that if you're writing a log, to write a message at the same time, increment a counter somewhere to say, oh, I wrote one of these types of messages, and use that metric data. You can still use logs for low-level troubleshooting, but most of your monitoring should be focused on metric data. So to kind of summarize with things, you want to be driving continual improvement. If you don't have any monitoring or you have very limited monitoring, that's okay. It's something that you continually improve and mature over time. Start with high-level black box service monitoring and try to use the same monitoring tools in production. Use them in your dev environment, use them in your QA environments, your testing. You might not be alerting people, but it can help. Sorry, my mic just died. Can you hear me?
Yeah, I can hear you now.
Too much talking, that's probably the issue. So you'll want to use those monitoring tools, use them in all your environments. And that can help with setting SLIs and your alert thresholds based on what you've actually seen in your testing environment. False positives, they help you identify alarms that need tweaking. False negatives and historical data can help you figure out where you need to add alarms or tweak existing ones. And you always have to keep that balance between, I want to be alerted as quickly as possible when real issues occur, but also keeping false positives to a minimum. And keep things simple. If your monitoring is getting complicated and brittle, and you have to keep going back to it and changing it every time you shouldn't have to go and rejigger your entire monitoring every time you make a service update. And also finally, make sure that you know that monitoring isn't free. There's a cost in time and resources, and you have to be wary of monitoring creep. If you're not using instrumentation, remove it. If you're not using analysis, get rid of it. Your alerts, your dashboards, always keep pruning the things you don't use anymore. The natural tendency is to keep adding more monitoring, but that can get out of hand as the days and weeks and months go by. So always be pruning out things that you're not using anymore. Okay, that's the end of the presentation. I'm going to get into a demo now, but is there any questions that anybody wants to bring up here? Okay. All right, I'm going to move on to the demo portion. How am I doing for time right now? 20 minutes, okay.
Looking pretty good.
Okay. I'm going to swap out my tab that I'm presenting here. Okay, can you see my Sysdig screen?
Yep.
Okay. So I know some folks have some experience with using Sysdig and some don't, but the idea here is I want to kind of show how to get, really it's about experimenting with what's available. I know there's a process for folks to get onboarded onto Sysdig, and what I would recommend is if you're not onboarded, get onboarded and just start experimenting. This is a dashboard that I made for that little app that I talked about. It's a kind of a customer-focused dashboard about requests and errors and response time of my little service that I created. But I wanted to show, for someone who's new, Sysdig, all monitoring tools have this problem. They're a little bit overwhelming because there are lots of things going on, and it's kind of hard to start clicking around and figuring out what's happening. So I'll just go through kind of how to get started with Sysdig. With dashboards, the one thing I can recommend is leverage what someone else has already built. Copy and paste with reckless abandon. If you like a dashboard, copy, take it, use it. The way you do that in Sysdig is they have a bunch of, they call them overviews, but they're just kind of high-level views of the cluster. But if you go down to dashboards, there are lots of pre-built dashboards here in the templates and here, and also if there's any on your team, you can see them up here. The one that I would recommend getting started with, if you're interested at the application layer, a lot of Sysdig stuff is kind of focused on cluster administrators. So the kind of CPU and memory and metrics of the nodes that make up the cluster. If you've got an application running on it, a workload, that's where this workload status and performance dashboard is a good place to start. Now inside these templates, you're not able to see what's behind any of the panels. So if you see something that's interesting, what I would recommend, we'll start this one, HTTP request per workload, is you can copy to dashboard. So what this does is if I have an existing dashboard, I can copy this panel to it, or in the case of here where I don't have an existing dashboard, I'll just create a new one. And I can go back to that page, and let's say I like that graph, and I also want this request latency one. I can copy that to my dashboard. So now I've copied a couple of panels that I thought were interesting, and I can go inside the each panel and make changes to it. So everybody has in Sysdig, there's something called a team scope, which is everybody gets a team. I think it's a synonym for a namespace in Kubernetes, and this just kind of controls what you're able to see in your dashboard. A lot of the default stuff is kind of for somebody that has access to the entire cluster. And if you're only interested in your particular namespace, when you copy things out of these template dashboards, one thing I like to do is to just remove all that chatter of things that I'm not interested in. So let's say I'm interested in this one workload, my refactored Enigma workload, and I'm not interested in all the other stuff. So what I can do is edit the dashboard scope to say that I don't want to see the other stuff. So I can say workload name. I can pick that. I can give it a smaller name. Sorry, I missed a step there. So as far as what's being graphed, I say I only want to see what my dashboard scope is. So now I've pruned out all those other workloads that happen to be running in my namespace to only the one that I'm interested in. I can get rid of that. And that scope is something that comes up a lot in Sysdig, is to make sure that you can set the scope to what you're interested in. I can also change the display here that it's showing me what namespace I'm in. Well, maybe I don't care about that, so I can just remove that as well to make it simpler and look nicer. I could also change that if I don't want an average, I can change it to things like, oh, I want a percentile and that sort of thing. So those some of those analysis features that I was talking about, you can use those as well inside Sysdig. Another thing you can do, keep that back as an average. So if I go back to this workload status, there's two types of data in Sysdig. I'm going to take this panel as well and copy it to my dashboard so I can show that. This will happen. So I've copied a panel and into my dashboard, and now it says you've chosen a scope variable that isn't defined in the current scope. So those default templates, they assume that you have access to everything, which isn't the case here. So what you have to do when you get that error is prune out the scope variables that you didn't include in your dashboard. So in my dashboard, I just have workload. I don't have cube cluster name and all these other ones. So I can just remove them. And that's how you address those sorts of issues. You're not going to break anything in Sysdig. This is all data that's been sent to Sysdig from your cluster, and you're not going to break anything. So you can go in and experiment and try things out without any concern that you're actually going to impact anyone else's work. From these dashboards, you can also create alerts directly from them. So they'll just look at your query and you can define alerts right off your dashboards. as well, and those can be handy as well. I would recommend not setting a notifier until you've let the alert sit for a while and you have some historical data. I think here they have, yeah, you can send Rocket Chat messages to channels and that sort of thing. But again, I'd wait until you've had some data to look at before you put those in there. And I think that's about everything that I wanted to cover. So if this would be a good time that if folks have questions, I'm happy to help answer them.
James, you got Andrew Cripps here.
Hi.
Hey, James, Andrew here. I have a question. What would you say is great presentation? Thank you so much for all that information. What would you say are the impacts on solution development for consistent application health monitoring?
It definitely, the earlier that people are thinking about monitoring the earlier in the application development process, the better. It can be really hard to add monitoring after the fact. And when the application is being developed, if people are thinking about, well, what metrics am I going to instrument? Where am I going to instrument them? How am I going to instrument them? That can really make a big difference when it comes time to release into production.
Yeah, and in your experience, do you find that there are standards or policies set up by organizations to define what sort of metrics should be collected and how they should be, how observability could be done with minimal modification to components?
If there are kind of standards for other parts of the process, if we're all writing in the same language and we're all using the same plugins, those kind of standards can fit in really well beside those.
Yep.
You definitely don't want everyone running off and doing their own thing.
Right. Okay. Yeah. Well, thank you. That's great insight. Thanks a lot.
Anyone else willing to put the hand up to ask James for any other questions? Well, we got him for the next few minutes. You got Connor over there. Connor?
Yeah, thanks for the presentation, James. One question I had, and I don't know if this is outside the scope of monitoring, but tracing, how does that fit in? Is that something that we can pull off the shelf into Sysdig, or is that more of its own separate thing?
What kind of tracing are you talking about?
So, for example, tracing requests across different services or different endpoints.
I don't think that's a Sysdig feature. I know other tools that do have that kind of, they can trace a call as it goes from your application stack to your back end and all that kind of stuff. I haven't seen a great implementation of it. Usually the demos look really good, and then you try to do it in production and you end up with this giant web of lines all over the place. And at scale, it tends to be less useful because there's, a million paths through your system, and having a trace from one end to the other is, useful, but it's just one of potentially a 1,000 different paths.
Right.
It could be good when you're, when things are broken and not working and you're trying to figure out, what's happening. Having a trace can be really valuable in the troubleshooting stage.
Yeah. Okay. Yeah, cool. Thanks.
Thank you, James. It was an excellent presentation. I'm sure we all learned something new about SRE and the best practices for monitoring. If there are no questions, I will stop the recording. It will be uploaded to our channel in YouTube in the next few days and will be added to our demo collection in DevHub. So keep checking the demo collection page, and the recording will be available there within a few days. Thank you, James.
Thank you for having me.
Thank you very much.
Yeah, spot on, James. Well done.